workshop on sensitivity analysis with integrated data, paper from the Census Bureau, and views expressed by me are not those of the Census Bureau necessarily. I have to say that. So this workshop is being jointly sponsored by FCSM, the Federal Committee on Statistical Methodology, and Washington Statistical Society. So for those of you who may not know, I have one slide here about FCSM. So the Federal Statistical System of the United States is not centralized. The functions are spread across 13 principal statistical agencies and a number of others. FCSM is the group that has representation from the various agencies, which pools expertise and advises the agency heads and OMB on and statistical issues. Federal employees, and we work together to pool information. Now, the impetus for this workshop is the broader context that we are increasingly being asked to use non-survey data and integrated data to create statistical products for various reasons. Survey data, traditional survey data are expensive, they're not as timely, and there's increasing demand and various pushes have caused us to start looking at very seriously how to integrate survey and non-survey data. And FCSM began 2 years ago to work on developing quality standards for programs and products that involve this integrated data. We have done a lot of work. We have had 4 or 5 workshops so far, yes, on this topic. And we are starting to produce reports. These are available at the FCSM website, and you can go there and right on the main front page, you'll see information about this effort. Now, I'll give a little bit of background on integrated data, and the first dimension is sources of integrated data. And this taxonomy came courtesy of Michael Elliott from the University of Michigan. We would have liked to have him to be one of the speakers today. Unfortunately, he wasn't able to make it. But he did give us a lot of pointers on how to think about this. And so if you're talking about where integrated data come from, he came up with 4 different sources. One is if you're combining data from multiple probability samples, for example, multiple frames in a survey. That's been around for a long time. Or you could be combining data from a probability sample and a non-probability sample. For example, generalizing results from a clinical trial, which is not representative but randomized, to a population, a well-defined population. A third source is when you have probability samples and administrative data. And administrative data, we're loosely defining as data collected for non-research purposes, covering a substantial part of the target population. Or you could be combining data from non-probability samples and administrative data. So that's the first dimension. And you can cross that with the second dimension, which is the structure of the variables that are involved. And we have different scenarios in this case. You can have a situation where you have key variables available sources, and they're close, but they don't always agree because nothing ever agrees perfectly. And then you have to decide how to combine them, whether to use this one or that one, or how do you do that. You can have situations where the key variables are partially overlapping. So some key variables are available from multiple sources and others are not. You can have a situation where the key variables are from entirely different sources. And you can have a situation where key variables from different sources are similar. They're attempting to measure something that's similar, but there's important differences between them. And you have to figure out how to harmonize the information. And that poses a lot of interesting problems. Are you going to treat one as a gold standard? Are you going to treat neither as a gold standard? What are you going to do? So you can think of those 2 dimensions as being crossed. And within cells of that 4x4 table, you can have various methods being used for combining the information across sources. And so these methods for combining are not mutually exclusive. You can have multiple methods for combining in a given project, and ones are appropriate depends on the structure of the variables and the sources of the data. So one set of techniques for combining involves what we call quasi-randomization inference, where you can think of it as modeling the selection mechanism. If you have a convenience sample or a non-probability sample, how do you generalize from that set of data to a population? Well, sometimes you may have to estimate a selection mechanism. And so that's what we call quasi-randomization. It's not true, it's quasi, because it's estimated. You can also have techniques that are loosely called record linkage, that includes exact matching, probabilistic matching, and entity resolution. You can have a situation where the units that you're linking together do not represent the same entities in the population. It's what we call statistical matching. It's just that they're similar, but not the same unit. Or you can do it more, things like that more explicitly with superpopulation modeling and imputation. And all of these are attempts to model the data generating mechanism as opposed to the selection mechanism. And then you can have a situation where, for example, if you're trying to harmonize sources where the variables are different, how do you harmonize them if you do not assume that one of them is a gold standard, but that none of them are a gold standard? And you can be doing something that the social scientists call latent variable modeling. And so, as I said, these are not exclusive. You can have projects where you are doing multiple of these at the same time. Now, this workshop today is focusing on what we call sensitivity analysis. And the reason why sensitivity analysis matters in these integrated data settings is that each of the methods that we use for combining information across sources is going to have assumptions. And these assumptions are often difficult to test, or perhaps they may be completely untestable from the data that you see. Now, depending on how the problem is set up, whether it's a model or not, these assumptions might not always be explicit, but some assumptions are being made implicitly in the ones that are more algorithmic. And we, as scientists, believe it's a good idea to try to make those explicit if they're not explicit so far. We think that integrity and transparency requires that we report assumptions and that we evaluate these assumptions as carefully as we can. That may include investigating what happens if the assumptions are violated. And that's especially important if these assumptions cannot be. We want to see how sensitive are the results to a range of plausible assumptions that could be made. Now, as we started to look at sensitivity analysis, we realized that people from health outcomes research, especially biostatisticians and epidemiologists, have more experience in sensitivity analysis than a lot of us at federal statistical agencies. They have been developing frameworks for sensitivity analysis for a while. There are books written on the subject, and often they do involve integrated data. And this has cropped up in lots of different ways. If you start Googling sensitivity analysis, that you'll see that it comes up when you're estimating causal effects with non-randomized data. It comes up when you're investigating dropout in longitudinal studies. Does the dropout depend on the missing outcomes or not? It also comes up when you're addressing measurement error and when you're trying to generalize results from randomized experiments, such as clinical trials, to a larger defined target population. And so we realized that in order to really make this workshop most useful to us, we would want to invite some people from this area to come and share what they know so that there can be a lively exchange of ideas. So the schedule for today has two sessions with a short break in between. The first session, we're very happy to have Sharon Lohr speaking with us on the topic of understanding sources of uncertainty with integrated data. So this is a very nice talk that she's prepared. She'll be delivering it remotely from Arizona. but we have an in-house discussant, John Elting from the Census Bureau, will lead a discussion or give his discussion, and then we'll have plenty of time afterward for questions from the floor and open discussion. We'll have a short break, and then we'll begin session 2, which brings in perspectives from health outcomes research. And we have excellent speakers from that area, Junaid Sadiq from Northwestern University and Ben Ackerman from Johns Hopkins. And as I said, audience participation, discussion, and brainstorming is strongly encouraged. This workshop has plenty of time for audience participation, so we strongly encourage that. So with that, I will introduce our first speaker. So, okay.
Should we let them know that we're recording this? So if people ask questions?
Oh, we're recording this. So.
Yes.
Yeah, and if you choose to ask questions, please be sure to use the microphone so that gets picked up in the recording, and also so that people who are participating remotely can hear what your question is.
Yes, thank you. Good point. We have well over 20 people participating remotely, and every time you hear a beep, it's someone else joining. They're not leaving, they're joining.
Reminds me of It's a Wonderful Life when you hear the bell, right? Sharon, I think we